Currently, the dominant approaches for robotic data collection primarily rely on teleoperation on physical robotic platforms or motion planning and scripted trajectories in simulation. However, these methods are either costly and hardware-specific or lack realistic perceptual and contact distribution patterns. Consequently, the limited scalability and diversity of available data have become key bottlenecks constraining progress in robotics. To address these inherent limitations, we propose a novel paradigm that extracts trajectories with diverse human manipulation patterns from hand-object interaction videos and thereby converts such visual data into training data for cross-morphology robotic learning. Given an RGB or RGB-D HOI video, our pipeline reconstructs high-fidelity hand motions in the world coordinate system using state-of-the-art methods, namely HEMR and MotionX++. For the manipulated object, a textured 3D mesh is generated via Hunyuan 3D, and its 6DoF trajectory is estimated using foundation pose. Finally, all HOI reconstructions are transformed into a canonical action space to mitigate variations arising from different camera setups or datasets. To enforce physically plausible hand-object interactions, we devise a physics-aware refinement scheme. Specifically, a TSDF-guided objective mitigates hand-object interpenetrations, while a residual reinforcement learning policy in simulation further sculpts contact patterns towards stable and realistic interaction. Leveraging physically consistent joint reconstructions of hand-object interactions, we generate hand-object trajectories that maintain stable contact, which are subsequently transferred to heterogeneous robotic embodiments. Within this Isaac sim, we apply domain randomization and diverse augmentations, including embodiment variations, trajectory distribution enrichment, object retrieval and replacement, background texture randomization, cluttered table configurations, and more. Using the RoboWheel pipeline, we construct HORA, a large-scale multimodal HOI to robot dataset comprising over 150,000 trajectories drawn from 3 subsets: a mocap subset, a recording subset, and a public HOI subset. Our recording subset is collected using a fully vision-based capture setup that is portable and practical. The mocap subset is captured with a synchronized multi-sensor rig comprising an 11-camera array and 2 EVT2 gloves, each with 29 magnetic encoders and 16 tactile sensors. Leveraging multiple open-source HOI datasets, the RoboWheel pipeline converts raw hand-object interaction videos into robot-ready data, which collectively constitute our public HOI subset. In terms of HOI reconstruction quality, benchmarking against methods like HORT, HOLD, and DiffHOI reveals our marked superiority in object reconstruction accuracy, hand trajectory smoothness, and hand-object pose consistency. We also conducted evaluations on 8 real-world household tasks across mainstream VLA or IL models, such as 8CT, diffusion policy, RDT, and PARO. We find that policies trained exclusively on HORA achieve performance comparable to counterparts trained on teleoperation demonstrations. Our additional experiments show that the proposed augmentation strategies substantially improve policy robustness under visual shifts.